Next question 8.8. A 5 kg collar is attached to a spring of spring constant uh, 500 Newton per meter. If it slides without friction over a horizontal rod, the collar is displaced from its equilibrium position by uh, 10 centimeters and released. Then calculate A. The period of oscillation, B. The maximum speed, maximum acceleration of the collar. Okay. So there is a 5 kg collar is attached to a spring of spring constant 50 Newton meter. Then it slides without friction over a horizontal rod. Then the collar is displaced from its equilibrium position by 10 centimeters and released. Okay. So collar means it is like a one ring. Okay. So one spring is there, and for that spring we attached that this is our, for suppose one spring, this is our one spring. For that spring there is a one collar. Okay. So collar means, okay, this is our collar. Okay. Like means one of the spring. Okay, its mass is given, that is equal to 5 kg. Okay. So the spring constant is also given, means it is displacing, that is when it is equilibrium position x is equal to 0, and it is displaced by uh, how much, that is x is equal to 10 centimeters. Then what is the maximum speed and maximum acceleration, and also period of oscillation for that system. So first write down the what are the data given here. So spring constant is given, that is equal to 50 Newton per meter, and mass of the collar is given, that is 5 kg. Okay. And displacement is also given, that maximum displacement that is equal to 10 centimeters is equal to 0.1 meters. Then it is a spring and block system. So time period of spring and block system, time period of spring block system means spring collar, spring and collar, and that is capital T is equal to 2 pi under the root of m by k according to our formula, spring and block system. In case of block, here we have a one collar. Okay. So this is equal to 2 pi under the root of m is equal to 5 by k is equal to, that is 0.2. So sorry, this is 50. If it is not 50, this is our 500, that is Newton meter. 500 spring constant is given by 500. Then this is equal to 500. Then 5 1 the 5 1 the 8 is cancelled, that is 2 pi under the root of 1 by 100, and that is equal to 2 pi by 10. Okay. And the time period t is equal to, this is 0.63 seconds. This is the time period of that spring and collar system. Then find out the maximum speed. So another question, that is maximum speed. Okay. So in simple harmonic motion, the maximum speed V max is equal to A omega. So then that A omega is equal to, here A is equal to, already we know that, that is 0.1 into omega. Omega is equal to, that is under the root of k by m, under the root of k by m according to formula. That is 0.1 into under the root of k. K is equal to 500 and m is 5 mass of the that collar. Then 5 ones are 5 ones are cancelled. This is 0.1 into under the root of 100, and that is 0.1 into 10, and that is equal to 1 meter per second. This is the V max or maximum velocity. Then acceleration at the distance. Okay, so second one is maximum acceleration. Okay, and that is a is equal to minus omega square x according to our simple harmonic definition. Okay, so then magnitude of this is a is equal to omega square x, that is a is equal to omega square. So omega is equal to, already we find out here, that is how much we got here. Omega is equal to this is 10, so I'm writing directly 10, or you can use the formula. This is here also, that is 10 into x. X is equal to how much? So that is 0.1, because we are displaced up to here. This x is equal to 0.1. Okay, so then a is equal to, here this is equal to how much? 0.1 into, okay, sorry, this is here, omega square is wrong. Okay, so write down omega square. So that is omega square. Omega is equal to under the root of k by m, and we have a square here. Okay, that is into x. So that is equal to square and the root cancel, k by m into x, and this k is equal to spring constant, that is 500 by mass is 5 into x. X is equal to 0.1, that is x is equal to 10 centimeters. Okay, and 5 cancel, that is equal to 100 into 0.1, and that is equal to 10 meter per second square. This is our maximum acceleration.